So as promised, I told you guys that I would work some of the application problems from the notes. And so we're on the manufacturing problem. It says the specifications for the dimensions of a new cardboard container are shown. If the volume of the container is modeled by this function, and it will hold 45 cubic inches of merchandise, what are the container's dimensions? So actually, these are pretty easy. Our function is basically our formula for the volume of this box, and it tells us what that volume equals. We know that the volume of the box is 45 cubic inches because that's how much merchandise it can hold. So that means that we could set up an equation that says 2h cubed minus 9h squared plus plus 4h equals 45. And so what I want to do is find out what h is, because they actually give me the dimensions of the box. The dimensions, at least as an expression, are h minus 4, 2h minus 1, and h. So I take this, I'm going to bring the 45 over to the left-hand side and set the equation equal to 0. And I want to solve for h. The quickest way to do this is to use your graphing calculator. So we'll open up the graphing calculator. I'm going to clear mine out. So that's second plus 712. And I want to put my whole function in because I want to know where y equals 0. I already have the 0 at the end. That's really my y. And those values are along the x-axis. So I have 2. Instead of h, I'm going to put x here just because of the calculator. And x cubed minus 9x squared plus 45, or sorry, plus 4x minus 45. And I'm just going to simply graph it and see what happens. I may have to zoom out to get all the values. I don't know yet. Okay, so it looks like it crosses in at least one place. I'm going to zoom out, so I'm going to hit the zoom and then zoom out just to see if there were any other values that I might be missing. And that pretty much looks like that's it. So I'm going to go back into my original part, so zoom back in. And I want to see about where that's at. It looks like to be about 5. And to be certain, I'm going to ask it to calculate that for me. So I'm going to go second calc, and I want the 0. I just want to pick a value that's left of 5. So I could pick 4 on my left bound. A right bound would be 6. And so my 2 arrows up there on my screen show me where the calculator is going to figure out my 0 in that interval. And I hit enter again, and I find out, okay, that my 0 is actually at 5. So my calculator tells me that h is 5. Now we know that there are 3 solutions because this is a cubic function, but what happened is we've got 1 real solution and 2 imaginary solutions. So we don't count the imaginary because we have a real box here. So we know that h is equal to 5. We just substitute that into the expressions that we have for the sides of the box. So h minus 4 would be 5 minus 4, or 1 inch. 2h minus 1 would be 2 times 5 minus 1, or 9 inch. And we already know that h is 5. So my dimensions are 1 inch by 9 inch by 5 inch. Looking at example 2, very, very similar problem. You have to be careful with the wording though, because it says the sales S of X in thousands of dollars that a store makes during 1 month can be approximated by the function. x in the function is the number of days after the first day of the month. So that's going to, basically that's telling me how many days it takes to make a certain number of dollars. We want to know how many days it will take to make the store $16,000. Keep in mind that S of X is in thousands of dollars already. So instead of using 16,000, we would want to change that to 16 because we know that's in the thousands. So S of X equals 16, and then we can set up a function for that, just like we did on the first problem. 2x cubed minus 2x squared plus 4x equals 16, and we bring everything over to one side. 2x cubed minus 2x squared plus 4x minus 16 equals 0. I'm going to plug that in my calculator. So clear out my old function. 2x cubed minus 2x squared plus 4x minus 16, and graph that. And again, I've only got one value. It wouldn't make sense really to have multiple values. It just means that my other values are going to be imaginary numbers. So it looks to be about 2. To be sure, we're going to go second calc and ask it to find our 0. A value to the left could be 0. A value to the right could be 4. And we find out that we have a 0 there at 2, which means that x equals 2. And remember, that's the number of days after the first of the month. So my answer is, it's going to take 2 days to get that $16,000. Actually, we're not going to worry about this one for right now. I'm going to mark that one out. And we'll look at the sales problem. It says the business plan for a new car wash projects that profits in thousands of dollars will be modeled by the following function, where Z is the week of operation and Z equals 0 represents the opening. We want to state the domain of the function. So, we just have a plain old rational function there. We know that the domain for a function is always all real numbers, except values that could possibly give us 0 if we have a denominator, which I'm going to say that there probably is. We want to take that denominator, which is 2z squared plus 7z plus 5, set it equal to 0, and see if we can come up with a solution. You can either factor this or you can use the quadratic formula. I'm going to attempt to factor here. And so I need factors of 5 that could potentially give me 7. And I'm going to have 1 here and a 5 here. And that's because my outer and inner terms are what make the middle. So 2z plus 5z would give me 7z. That gives me z equals negative 5 halves and z equals negative 1. So that's going to affect my domain because at those values I would not have part of my function. I could potentially have an asymptote there. And I get, sorry, I guess for my domain, I probably want to use a z instead of an r. Z cannot equal negative 5 halves or negative 1. So that's my domain. We also wanted to determine any vertical or horizontal asymptotes and graph the function. So our vertical asymptotes would be where we have some empty space, I guess, in our domain, unless our numerator and denominator would have common factors. And in this case, they do not have common factors. So my vertical asymptotes would be z or x equals -5/2. And I'll just put a little x here to remind us that that's what it is. And z equals -1. Do I have any horizontal asymptotes? Well, it kind of depends on the degree of my numerator and my denominator. The numerator has degree of 2 and the denominator has degree of 2. So that means n, which represents the numerator, is equal to m, which represents the denominator. When that happens, we take the leading coefficients, and that makes our asymptote, and we get y equals 3/2. The last part asks us, well, we could do intercepts, but then we just want to graph our function. And I'll kind of leave that up to you here, but I'm just going to put in my asymptotes for right now. I know I have vertical asymptotes at -1. And I have one at -2.5, which is -5/2. And I have a horizontal asymptote at 3/2, which is 1.5. So probably about right in here. So those are the sections where things are going to start to happen. If I graph this function, I can have a fairly good idea of what might happen. Clear out the old function. You just have to remember to put your numerator and denominator in parentheses if you have multiple terms. So I actually do here, I'm going to put my numerator in parentheses and say 3x squared minus 3 for my numerator. And for my denominator, in parentheses also because it has multiple terms, 2x squared plus 7x plus 5. And then you can graph that. So I can see kind of what's happening on my picture there. And I had something that looks like this, and then I guess I actually have a hole here at -1. It's going to be like this. And we have a hole at -1. I said that it wasn't factorable, and that's not true. Or it is factorable, but what happens is if I'm looking at this guy, when I can factor out a 3 and get x squared minus 1 over 2 x plus 5 and x plus 1. That numerator would factor out into x plus 1, x minus 1. This tells me that I don't have a vertical asymptote there, that I actually have a hole where x is equal to -1. It's kind of nice to be able to graph that just so you can confirm it. And then the last one is just asking you, the one about the water is just asking you to follow the directions. It says graph the function using a graphing calculator. Then graph the line, y equals 8,000, and find the intersection of the two. What % of salt can be removed for $8,000 a day? So you're actually going to graph two different lines, find their intersection, and that will, your X value will be how much salt that they can remove. And then part C wants to know, is it feasible for the plant to remove 100%? And the answer is no, because if I look at the domain is limited to values less than 100. Okay, you have some work to do on 2.4, 2.5 problems, and then you also have a review.